Okay. Well, the first thing I'm going to start out with doing, I guess, is just downloading a model online because most of the models that we're using in our projects right now, we're getting from online just because we're not 3D printing most things. So
Yeah.
this is the hot end and extruder I think every group is using, right, Jason?
Yeah. Yeah, but if you're not
Yeah.
a part of the project for 3D 4E, this is just a 3D printer project we have going on right now. But this is just an example of when you're buying a product, if you go down to like the description or the resources in the product description below, you can find 3D models for a lot of products that are typically used in design. Like
Yeah.
screws, you can even find 3D models for, and just so you don't have to make them yourself, you can just get them from the manufacturer.
And most of the time when you download files online, it comes a step file because it's accessible in almost any like 3D modeling thing. It's not specific to any one program. And then I would download this, but I already have, and it would just take too long. So once you open that up in SolidWorks, it'll look like this. This is a step file. This is a step file of an assembly, so there's a bunch of different parts that make this up, but that doesn't really change the process of saving it as a SolidWorks part, which is something you want to do if you're using it in an assembly because sometimes you put in step files, you get like weird errors and stuff. So I'll save this as a SolidWorks assembly right here. It's already default. I'll just change the name.
Yeah, and the reason why you do an assembly is because this is an this step file is actually an assembly of multiple step files.
Yeah. If you just have a normal part, then you come and save it as a SolidWorks part, but that I don't think is an oh, it is an option actually, but since this is an assembly, I'll save it as assembly.
Yeah.
Yeah. Okay. Maybe I should have paid attention to where I saved it, but I don't remember. I'm gonna save it again.
It's in
Oh,
here
actually, it was
this
where I
time.
wanted it, which is good.
Nice.
All right, now I'll open that. Well, it's already open. Now it's saved as a normal SolidWorks part or assembly, not as a step file. And we can import this into another assembly real
Oh,
quick.
so wait. When you make a new thing in SolidWorks, you have three different options.
Yeah,
When you go to new template, it allows you to make a part or an assembly or a drawing. So a part would
yeah,
be an individual object that you're designing to be a 3D object. An assembly would be importing those individual parts together and constraining them together to be a product with multiple parts to it. Like this Hemera extruder, for example, the motor is separate that from the other parts. You can see, yeah, he can highlight each individual part. It's an assembly of multiple parts.
yeah. And a lot of the parts that I have here are things that I downloaded online. Like this stepper motor just followed the same process. This one is just a part, it's not assembly. That's why you have all the features of it here instead of the different components that make it up. This right here, this aluminum extrusion is one that I made. It's it's just one sketch and an extrusion, and I'll show how to do that later. But this is just one of the parts that I was going to use in the assembly to have that and extrude it. And so I'll start assembling some of the parts that I downloaded online real quick, just so we can have an idea of making something. So I'll open a new assembly file right now. And right when you open it, it wants you to put in your first file. So I'll start with this aluminum extrusion. And I want to orient this in a certain way, just so it's facing upwards,
Yeah,
like that.
so that thing in the bottom left-hand corner allows you to rotate about a certain axis, and you can see in the very left bottom corner, you can see which axis is where.
Yeah. And then you could just put it anywhere in the assembly. Now we have this. This is, let's say we're going to make a Cartesian printer z-axis right now. So another part that we'll need to do that is a linear rail or some sort of rod. In this case, we're going to use a rail. So I'll insert another component. and I have that rail right here. This is another thing I downloaded online using the same process. So I'll just click the wrong orientation. Let's see, rotate about the Z, Y, and this should be good. So we can just stick this in here. And then, as you can see, these rails are mounted just by putting some screws in through here. You have a bolt on the other side, or nut, that slides in these T-nuts. So because I don't want to model every single one of those constraints, because it would take forever and not really do too much for me, I can combine these two parts using a mate. And the first mate I want to make is I want them to be touching, I guess. Just these two faces to be right up against each other. So to do that, all I have to do is just click the two faces. I'm going to move this so it's easier to see. Oh, well, that's not what I wanted to do. So I'll just undo that. And I'll move this first so it's easier to see what's going on. So I want to mate these two faces to be up against each other. All you got to do that, just click them both. It'll automatically assume what you want to do and put them together.
Yeah, so he's using a coincident mate to do that.
Yeah. And then another one, which is more of, well, it's literally called an advanced mate. I'm going to use this with mate, which is pretty convenient for constraining these rails, because you just click the two surfaces of this and the little tabs that you want them to go into, and it'll just constrain it right here. So you would just screw these in. That's how it would be in real life.
It becomes
It's a convenient
centered.
way to,
Yeah.
yeah, it just centers it like within a tab.
If you were to zoom in closer, you can see that basically the distance between the blue and the purple faces are the same on both sides, which makes it centered.
Yeah, it's just a convenient mating tool to align these rails in quickly. Yeah, and right now this is not fully constrained, because if I were to drag it around, it would still move, because it's not completely mated. And you can tell because it has the minus sign right here that it's not fully constrained. This one is fixed because we put it in, and the first one you put in is by default fixed. It won't move. But let's see. We can put in another component, because we don't want this rail to be all the way at the bottom, because we're going to have a motor here. So we'll put in the motor right now.
And that thing on the left, that's called the Solidworks tree. So that's
Yeah.
basically the name of that drop down with all the parts, where he was showing the F and the minus sign. That's what it's referred to by SolidWorks and in industry.
So let's say we wanted to put a motor in. We could just mate it up against here. But for the motor, in real life, we would have a mount that goes on. And with this, you just screw it in. So it's pretty easy to just do it like that. But we want to design a mount that can hold this motor in place so that we can assemble it in real life. So we can start by making a new part first. We have to take some dimensions. And you can use this measure tool in the evaluate thing to get
Here.
dimensions really easily
I can
between
jot
like
them
these
down for you.
holes, put it that way.
I can jot them down. Tell me distance between holes.
Yeah. From the centers of the holes, it's 31 millimeters.
31 millimeters.
Mm-hmm.
Got
And
it.
like right now, we're talking about making a bracket to connect this to this. So we would need those, and this is just a square, so it would be the same.
31 millimeters. Nice.
And then we also need an empty space in the middle for this to stick through. So that is 22 millimeter diameter at minimum for that hole.
Yeah, you have to keep in mind when you design things, especially if you were designing something to be 3D printed, there are certain tolerances that you should be aware of, and your part isn't going to be completely what you design it. There's going to be a plus or minus 0.1 millimeters, plus or minus 0.5 millimeters even sometimes. Depends on how you manufacture it.
Yeah. Okay, so now that we have some dimensions, I guess we can just come up here, make a new part, and this is going to be a mount for this motor. You start out by making a sketch, and we could do that on the top plane here.
Yeah. Wait. If you go back for a sec,
Okay.
the reason why you would define it to be on a certain plane is basically how you want to think about how you're going to import it into the assembly file, and you just kind of want to make it easy on yourself so you don't have to rotate it as much based on how you define the body. You have to keep in mind, you have to go into a design thinking of how it's going to come out, you know.
Yeah. Like I could just orient this little thing right here is what I'm looking at when I'm spinning it, by the way, just to make it nice. You could just do the top plane here. Okay. So first thing we could do is make a little rectangle. Now we can dimension it.
And that was a center rectangle. It's a
Yeah.
drop down under the rectangle tool.
Mhm.
Or no, is that the standard one that they give?
No. I think that you start with a corner rectangle.
Okay. Yeah. So it's just another type of rectangle.
Yeah. So since the first thing we got were the holes, we can actually just, this is an easy way to do it, come here and make this a construction geometry and put all the holes on this thing. Because we know the holes are spaced out in a square. We can come here, make this the size of that square, which was just 31 by 31 millimeters.
Yes, it was.
And then, off my memory, I'm pretty sure these were 3 millimeters, but make them a little bit more just so, let's say we're going to 3D print this piece. Just give the a little bit of room for error for the screws. And now one thing, so you don't have to come dimension every single one of these, you just control click all of them and just make them all equal. Do that. And right now we just have holes. We want a whole body. So we can come here, make a little surface. Let's say we just make this 40 by 40 for now. Okay. And then we can come here and turn it into a three-dimensional part by just extruding it.
Yeah, you have to go to the features tab at the top. Before he was in the sketch tab, and now he's in the features.
Yeah. Okay. And let's just make this 5 millimeters, why not? Yeah.
Oh,
And you might have
Matthew,
noticed that I've forgotten something.
you forgot.
And that's okay, because you could just come edit the sketch.
It was 22 millimeters, by the way.
22, yeah. I'll make it a little bigger than that just so it fits. Okay. Come in there. We'll make it 25.
Nice.
And then we can exit the sketch, and hopefully it knows what we wanted it to do, but if it didn't, we could just come and edit the feature again to tell it, let's say maybe we want to fill this, or just do this hole, or just do these sides. Oh. Click something weird. You can come and edit anything you want, basically. Yeah. So this part would hold on to the motor, but we still have nothing to connect it to the actual aluminum extrusion, so I could make another piece on here. Just come in and start making a sketch right here. I'll start with a corner rectangle. Okay. You can see it's not snapping to that bottom thing, which I would want it to do. That's a pretty easy fix. I could just come, control click both of these, make them collinear. And let's see. Now, our piece on the aluminum extrusion is going to, I'll make a center line right here just to help draw some stuff.
Yeah, so that's a construction line. It's called a
Yeah.
center line, but it's used for constructing other sketches.
So we want to make some holes to mount them right here. Basically slide a nut down, screw this motor right into these slots. These slots are, I believe, 40 millimeters apart from the centers.
How do you measure that? Yeah.
I can measure the sides here, and it'll tell me these are 14.7, and the outside ones are 25. They're about 10 millimeters in width.
Yeah.
Yeah.
If
Okay.
they're 10 millimeters in width, it would be the distance between the inner sides divided by 2. No, yeah, divided by 2 plus 5 if their width is 10. So it would be like, what was it, 14.2? Is that what you said it was, the distance of the inner edges?
Yeah, it was around there. You rounded
Yeah.
to like 14.
So it's like
That's fine.
7.1 plus 5 is 12.1.
One thing I'm going to do is make this midpoint line, and I'm going to make sure that this is horizontal. So it's completely horizontal. And I'm going to make it for construction because this is just to help me place the holes where I want them to be. And let's see.
Yeah, so the
Two
difference
circles
between a
all the way
construction
around.
line and a normal line is that a construction line doesn't define the geometry of the sketch.
Yeah, it's just for construction. And I could come in here, I'm pretty sure 20 millimeters is what they should be, but once I put it in, we'll see if I'm right. And then
I don't know,
I'll
dude. I
also
think it should
smart
be
dimension these.
12.1.
12.1, well, I guess we'll see.
I might be wrong, yeah.
Um, how big should these holes be? I don't remember, but I'm gonna make them 4 for now.
Well, typically you'd use an M5 screw.
Oh yeah, you're right. I'll make these two equal just like I did before. I'll make it like 5.2, just a little bit bigger than the screw size. And the blue means that it's not fully constrained. As you can see, you can move around. So I'll constrain it a bit more. About 10. Now, in reality, I would have to make sure that the heads of the screw wouldn't interfere here. So I'd want to make it just tall enough for them not to hit anything.
Mm-hmm.
And then I'll do this as well. See what 20 looks like. That's a bit too much. I've got a lot of unused space. I just want enough for this hole to be fine. That looks good to me. Okay. Now come with another extrude. And I could leave it at 5 millimeters, sure. Now, let's say we were to 3D print this part, we could do it in a bunch of different orientations. Bottom, from the side. I'd probably print it like this just so the layer lines are the strongest at these corners. Well, I guess we'll get into that later. But just keep that in mind. It's
Yeah.
nice. You could also, for strength, fillet this, but since I didn't leave a lot of room, obviously you're not going to have room to screw things in.
Well, not for do
So
like
if
a
I
two
wanted to
millimeter
fillet
one.
it, yeah. If I wanted to fillet it, I'd just leave more room for a fillet, or I'd make a very small fillet, like that. But that would still probably interfere here,
A little
and
bit,
it would
yeah.
probably still interfere. So I would make it bigger if I wanted to put a fillet. For this, I don't think it's really necessary. I'll come in and save this. I'll just save it as motor mounts for the Z-axis. Then I can go back to my assembly and bring that in. And, I guess oh, here it is. Okay.
You see, because he defined it on that one, he started his sketch on the top plane. When he popped into his assembly, everything worked how he wanted it to.
Yeah, it was just already in the right orientation. I didn't have to finick with it, which is nice. Okay, so right now I'm just making the holes concentric, just all lined up. Do that one, and then it could still spin. Well, I guess I can't show it, but I want to make sure that I have at least two of the holes constrained so it doesn't spin around that axis. Then I want the faces to come together. And then I want to mate it to the actual aluminum extrusion. So I can start with face mate. And then I can mate these same way I did this with a width mate. So I just select the tab and then the hole. And I'll just put it right in the center.
That's pretty cool.
And then hopefully that'll work over here. If it doesn't, then that means, honestly, it probably won't because I didn't make sure it was completely right. I need to make sure I have width mate selected.
Yeah, it's under the drop down for advanced mates. In case you can't find it one day.
Okay. So 20 millimeters was right because it's not giving me any errors and it is
Yeah.
mating. So that's
It
good.
looked right. It looked right. It makes sense.
Yeah. Okay. So now we have this mounted. It's still free to go up and down, but I'm going to change that because I don't want it to do that. I'll just mate this bottom face so they're just flat with each other.
If you want to create an offset with that bait, could you? How would you do that?
Okay. First I have to get rid of the one I just made. So I'll just undo. Let's say I want it to be like 40 millimeters above the bottom of this. Oh, I clicked the wrong thing. My mouse accuracy is not great. We would come here and make this one. It's just a distance mate. So it'd be kind of the same process. I click these two, except I specify the distance, let's say 40. And let's say that was the wrong direction. Just flip the direction, and you can get it 40 millimeters in either direction. But I don't want that. I want it to be coincident, so that's what I'm going to use. Okay, so now we have a few things assembled together. And now that I know kind of where I want this thing to be, I can just mate. Actually, I can use a distance mate here. Say I put some distance between this and the rail. And let's just say 20 millimeters of room.
Nice.
Now everything in here is fully constrained. There's no more minus signs in front of the names. It's all constrained. And now another thing that I downloaded online was the actual connection point on this that goes up and down. So I'll just
The
insert
carriage for
that.
it? Okay. Yeah.
This thing. I don't remember what it's called, but
It's called a
it slides up and
carriage.
down on here.
I think it's called a carriage.
Yeah, maybe.
I've been calling it that.
Let's see.
No, I said about the Z, yeah. Okay.
Yeah, here we go. Okay. This one's a little weird to put in. It's supposed to slide up and down, so it won't be fully constrained, at least for us. I'm just gonna constrain these points together, because that's what slides along it. I could use a width mate again, but I won't be doing that. I'll just constrain these faces, because they would kind of be touching as it comes up and down. So I'll do that one, and then the one on this side. Now this should be able to just move up and down, like that. So if we had the rod and all the stuff in place, I guess maybe I should save this. Save all, sure. And I'll just save this as Carriage. Yeah. So now that we have this, let's say we wanted to mount something onto this block. Let's say we want to make a sheet metal piece to mount that on. We could do that. First, we'd need more dimensions, which is just going to be the dimensions between these two holes, 20 millimeters, and then I think it's just a square with 20 millimeters, yeah. But this time we'll make it out of sheet metal. So let's go make new part. And then this is the sheet metal toolbar. It's not there by default. So what you got to do to get it there is I think you come here to the toolbars, and then you find the sheet metal toolbar in this long list. For me, it's right here. Click that. It made mine go away, but if you click it for you, it should make it come. All right. So first thing, we make a flange. It's much like making a sketch, but for sheet metal. We'll do it on the top plate again. We don't actually, ideally, we wouldn't have it on the top plane, but it doesn't really matter too much. So I'm just gonna do it. And first thing, like last time, I'm just gonna put the holes because I just remember those dimensions. They're fresh in my head.
20 by 20.
Oh yeah, easy to remember.
19 by 19, yeah.
Okay, and then again, just to make all these equal.
It uses an M3 screw, probably.
They do, yeah. They use an M3 screw. I'll just make them a little bigger. And this is 20.
Yeah, even
And I
with
don't
sheet
actually
metal
have to
piece,
say between this. What's
even
up?
with sheet metal parts, you should make things a little bit bigger for holes. It's not just 3D printed parts that need to be toleranced. Things
Yeah, you
aren't
don't want it to be just a
exactly.
little too small and then you have to hand drill out the holes so your screws fit. That would be annoying.
Mm-hmm.
Okay, and
Okay.
then this can be arbitrary, I guess, because we don't have any specific requirements.
30, really?
30. Yeah,
Okay.
I'm probably actually going to come back and change this later, but for now I'm going to leave it like that. And you can come here, this thing. Instead of doing the extrude, since I want it to be a sheet metal part, I clicked that flange is what I did. And you can read the description of what it does right there. It explains exactly what it is. So all the parts that we're going to order for the printer project are going to be 1/8 of an inch thick, so I'll just tell it to do that. Wait, is that right? No, because that's
That's an
1/8
eighth
of a
of a
millimeter.
millimeter.
I was thinking that was a little small. There we go.
Yeah, so if you type in, if your page is in metric, if your proper document settings are in metric, you can type in any kind of math or any kind of unit in the
Yeah,
dimension tool, and it will convert it to
it just
metric.
converted it, which is convenient. So now we got this thing. I could save it and import it. I'll just name it block mount. Right now, all it does is screw onto the thing, but in reality, we want it to actually mount another one of these rails on, so that we could have another axis that comes out. So I'll just do that real quick. In order to do that, we need to be able to screw at least 2 of these in. If we just have one, then it's going to rotate about that axis. It's not going to be fully constrained. So we want room for 2 holes. Let's come here and measure what the distance between these holes are.
32.
25, Jason.
25.
Pretty
That
good.
was off.
Yeah, and diameter is 3.5. I'll try and remember all those numbers.
Okay, I'll write them down. 25, 3.2. I got them.
Okay. Now, I'll come back and edit this and put those holes in. Let's just say put them out here. If we want it out here, we're going to have to get rid of this line. So you could either just click it and click delete on your keyboard, or you can come and, where's the tool? Trim entities and just boom, get rid of it. Makes everything else no longer constrained, but that's okay for now. You come in,
You
make
can,
some more lines.
if you're ever drawing a sketch and your sketch isn't shaded in, it's because it's not completed.
Yeah.
The
Like how it is
circles
right
are
now.
shaded in, they're completed, and boom. Yeah.
And then I want to put some more circles here. 2 more. Yeah, I'll make them all horizontal with this circle right here. Oh. There we go. Now all those points horizontal. And I'll come here, smart dimension these two to be 25 millimeters apart.
Yes, indeed. Oh boy.
And, well, that's okay, that's okay. I'll make it 10 millimeters away from here.
That only made it worse.
Don't worry, just drag it there. Come in, smart dimension from here to here. Make it 65 millimeters, sure. Oh.
Very cool.
Yeah. Then make it 10 millimeters thick, sure. Okay. And, oh boy, yeah, we have this problem here. So I'm just gonna make these collinear. There we go.
Nice. 3.5.
Okay. I'll just make them 3.5. I mean, yeah, I think that's fine, because the screws are gonna be... What kind of screws do we put in there, Jason?
Oh. Actually, I don't. For the this, what is this for?
The rail.
It is.
Yeah.
Well, they're gonna be 8 millimeter gun 3 screws. I
Okay.
guess the ones that we were getting. Yeah, but they're gonna be M3.
Okay. Yeah. I'll put a sketch fillet here. Just, it looks a little nicer.
Ooh. Adding a little bit of curvature. Nice.
Yeah.
And when you get a sheet metal, when you get a sheet metal piece, the corners are sharp.
Yeah, actually, that's a good point. But I'll do the other fillets out here.
Yeah, if you were to manufacture this, the corners would be pretty sharp.
Yeah, so it's a good idea to come in and just do some fillets on all the sharp edges. So close. You don't need them to be that big, but I'm just gonna click all the corners first. And then I'll adjust the size of them. Okay.
Oh, it's like a wait. What does that look like to you? Okay.
What did you mean?
It just looks sharp, like a knife.
I don't know. Okay. Maybe 1 millimeter is too small.
No, that looks
There are
good.
no sharp corners. It's nice. I'll save it again. And I'll bring it in to our assembly. What did I call it? Here it is. As you can see, I saved it on the top plane so it came in the same orientation as that. Just one click away from being correct. Oh, I accidentally placed it inside. So I'll make sure those circles match. As you can see, if I only do one circle, it likes to spin, so
Oh wait, can you change your viewpoint before you move on, just so you can see how the circles are still concentric, but it's moved further away.
Yeah. Oh, that didn't help.
No, yeah, it's kind of hard to see sometimes, but
It's okay.
yeah, it's fine.
Yeah. Just make sure they're all right.
They look all good to me.
Yeah, and these would just screw into place because these are threaded holes in reality. They don't look like it here, but they are.
Ooh, okay.
Yeah, it looks weird, but it's okay. And now, for the reason we put these in, I'll import another one of these. What was it called? Here we go. Okay. First thing I'll do is these faces, just so they're... There we go.
Nice.
Command. You can click through the piece after you've clicked it once, which is convenient. Make sure those are good. Okay. And now we have half of a carriage assembled. If we wanted to complete this printer, we would make another
Well,
one of these
you
on
can
the
mirror
side.
it. Just mirror it. Define a
You
point and
could
mirror it.
mirror it.
You do it now.
Yeah, but I would have to make a plane directly in the center of this to mirror it.
But that would be awesome to see how to do that.
Okay, sure. Let's say I didn't want to have to remake this entire thing, and I wouldn't want to. I would just mirror it, and I'll show you how to do that. So we'll make a plane first to mirror it around, and we'll make that plane directly in the center of this by picking this side and this side of it, and we'll just automatically assume we want it in the center, which is what we want, so that's nice. We have that plane now. Make it a little bigger though. Okay. Now I can come here and view planes, so it doesn't disappear. And then come use the mirror. Where is that mirror?
I think it's. I don't know.
Um,
Um, Look under linear component pattern.
Here it is, yeah. I always lose these things, but they're not too hard to find. Okay. First thing it asks us to select is the mirror plane. That's this plane. Then it wants all the components we want to mirror, which is everything except for this, because we only have one of these that we want to keep. I'll do that. How? It's okay. I want to mirror all of that about that, and let's hope it works.
It should work.
There
Nice.
you go. So now we have the majority of our carriage done. Moves up and down. We can mount our extruder onto here, which I could do, but it would just be more of the same that I've already done. So I'll just
Perfect.
get out of that. Okay. But now, as you can see, we have a sheet metal piece, and in order to make this into a file that we can actually put into the machine to cut it, we have to save it a certain way. So I'll show you guys how to do that because you're going to have to, so we can make these parts exist in real life. So one quick way to just open these parts, by the way, you just come and do that. So we need to save these as, I'll do as a copy and open as a DXF file is what you use. So flat pattern, save as DXF, click save, and it's going to take you to something. That's okay. Okay. We want this face, basically, to be exported, and that should do what we want it to do. So if I do that, we get this file, and this is what the machine actually uses to cut out what we need. So we come here, we click save, and let's see if it's where we wanted it. Oh god, there's so much. And then right here, DXF file, this is the file that we would want you to send to us so that we could cut out your parts.
Yeah, that was nice.
Yeah. And now if you have a part that needed to be 3D printed, there's another type of file you need to save it as. And let's say we wanted to 3D print this. You need to come here, save it as, I'll just save it as a copy and continue. You need to save it as an STL, which is here. So I'm just going to name it a different name so I know it's an STL. And you save it like that. Okay. And then once you build your printer and you're printing stuff like this on your own, you want to download a program like Cura that can open STLs and slice them for you. You come in here, click open, and you go to wherever you saved that thing, which for me is
Where is
somewhere in
it?
here. Here we go.
There.
And you open it. And you want to keep in mind orientation for this. I think the best orientation would be to print it on, oh man, where's the rotation? Here we go. I'll print it on that. Is there a lay flat feature to
Yeah,
this?
there
No.
is. It's that thing right.
Here we go.
Yeah. There you
Yeah.
go.
There. So, yeah, you come in here, mess with your settings to get what you need. Come in and click slice. Just get rid of that.
The preview's at the
Come in
top.
your
Yeah.
preview.
Oh
Then
man, you have
this
all the
is the part.
travel movements turned on.
Yeah.
That's fine.
It's not too big of a deal. Those blue lines are just where the extruder is going to move between parts. The red the red, yellow, and green is what will be printed. I guess I could just come here and change it to material color. Turn off travel lines for Jason. And this is what you'd have.
Yeah. Thank you. Yeah, you can even press the play button and it'll show you the top layer, or whatever layer on, it'll show you its movements.
Yeah.
Which I think
So
is
you
pretty
can
cool.
come and do that. You can come and check out the infill. I'm gonna go back to it's line type.
Yeah.
You can see the infill and everything. The reason I chose to print it in this orientation is because 3D prints are the weakest along the layer lines. That's where they're easiest to break. And I wouldn't want the layer line to happen right here, because then it would just break right off the thing. Like this, it's the strongest on this corner, which is where I'd want it to be the strongest to make sure my motor doesn't fall off the bracket.
Mm-hmm. Yeah, because the force on this thing is going to be downwards.
Yeah.
So you want to just make sure that the weakest part of the seams between layers don't happen along that.
Where the force is going to be happening, really. So yeah. Is there anything else you think I should go over, Jason?
Yeah, go back to the 3D print real quick. I just want to cover one thing. Yeah, if you were to look at that circle, those aren't going to be real circles. They're not going to be perfect circles, at least. You can see it very clearly there. Yeah, they're going to be slightly ovals. And that's
why
just
it's nice to make them a little bigger than they need to be, just slightly bigger.
Yeah, for sure. Just because of the accuracy of how the 3D printer moves. And something like this probably won't need support material, but if you want to turn it on for the big hole, because if you look at it, it's printing over nothing for a little bit of a chunk there. Right now, it's not going to turn on anything because he has a touching build plate, but if he had it
Yeah.
everywhere.
There we go.
Support placement everywhere. It would do support in that hole, in all the holes. Well, I guess most of the
Yeah.
holes.
Yeah. In reality, I probably wouldn't do that just because I think it would print fine in this case. Holes are most accurate when they're face down on the build plate. So you can see why if I make it face down on the build plate.
Yeah, you have the least amount of accuracy with your. Oh, don't rotate it, dude. It's gonna be twisted.
No, it's fine. I'm just gonna tell it to lay flat and it'll pick this up.
You have the most degree of accuracy on the XY axes. You lose a lot of accuracy on the Z axis because that's where the layers jump up, and that's the
Yeah.
least accurate bit.
It's, as you can see, a more perfect circle here than it is here.
Yeah.
You can kind of tell,
And you
right?
can adjust that too if you want a more accurate model with less with more curvature everywhere. You can adjust the layer quality, the standard quality, the it's each layer height. So if you were to reslice it at like 0.05 millimeter layer height, it would be a better circle.
Yeah, I guess I can do that. Why not? I'll come to 0.01.
That's 0.1, but fine.
Oh yeah, you're right. I meant 0.1. But
Mm-hmm.
now all these lines are thinner, basically, is what it changes. And the resolution of the circle is higher.
Yeah, except the print time is now double.
Yeah, because
It's
there's
actually going to be
twice as
double.
many layers.
Yeah, exactly twice. Well,
In
almost,
this case.
approximately twice.
And the reason that I wouldn't print it in this orientation, even though the holes are slightly more accurate, is just because now this is like a very weak part and it's likely to break there. But if I had a fillet here, I wouldn't really care too much. It would probably be fine. I mean, those are all just little things, but it's nice to keep in mind.
Yeah. I think we have like about 10 more minutes, so I think we should go over how you would design something with a chamfer if it's bridging in SolidWorks.
I mean, I could show how to make a chamfer. I don't know what you meant by like
Like
for
if
when
you
it's
were to
bridging.
design a bridge underneath the bridge, you would want a chamfer just so or like I guess not really a bridge, just something with like an overhang. Yeah, if you were designing an overhang on a part, you would add a chamfer if you wanted it to be 3D printed.
You mean like when it's touching the build plate?
No, I mean like let's say like a balcony or kind of like a deck. You would want a chamfer underneath it. It's kind of hard to explain. Just go to SolidWorks and make
Okay.
like yeah,
Should I come
I
in here
guess
or make a new part?
yeah, make a new part.
All right.
Like trying to think about how to describe it. Like
I
if you
think I
got
know what you mean, but
yeah,
you tell me if I'm doing it right.
okay.
Say I were to just come in here, draw a shape that kind of looks like this. Saying it should have a chamfer here. Oh, I clicked again. Like between these two corners. It should have like
Yeah, I guess a bridge was kind of a weird example, but like just something with like an overhang where like let's say you only had half that model, like the left half or something.
okay, yeah, I know what you mean.
Yeah.
Like this.
Yeah.
And you want it to print on the bottom surface for some reason.
Let's say the sides are curved or something, so it would be even harder to print on those. Oh yeah, it's easy to print on flat surfaces. So if you want something
Well,
to
you
be
have to
3D
print
print,
on flat surfaces,
you can
pretty
just
much.
you use a lot of support material and
I
clean
guess
it.
technically.
Yeah, but you'll get a lot less quality parts if you don't print on a flat surface.
Yeah. Do you want me to make these curvy for you?
Yeah, you can do that.
Okay. I'll just make a random shape with a spline.
Have fun with it. have a lot of fun with it. Oh, that is random.
Yeah. So we had this shape.
That looks like my hairline.
Okay. Extruded this, like, I don't know. It really doesn't matter how much I extrude it.
Mm-hmm.
Let's say we have this and we want to print it. We would have to print it on this space right here. And we would still need support coming out here just for this part.
Yeah.
But this couldn't really print. It would come out and come back and then it would just all droop down. There's nothing to support this side. So
You can either add a lot of support material, like that blue stuff that you saw in the slicer, or you can design the part to not need that.
yeah, I could just come with a chamfer. A fillet would work too here, but
Mm-hmm.
I make this chamfer bigger. I don't know exactly how big though. I didn't mean to put 2,000. I wanted to put 20. Okay, maybe 50. Too big.
40. Oh, 40 is just right, or almost. It's
Almost.
close. It's
Yeah.
close. 45.
Part would still droop.
Still be a little bit droopy.
Yeah. Can I like? Oh, oops. I mean, in reality, if I were to do this, I wouldn't use a chamfer. I would just come and change the sketch. Have a line from here to here.
Yeah, you can. You can do that. This is a weird example we're throwing in at the last minute because we had extra time.
Yeah. I would just come and do something like this.
What an amazing thing that we designed.
Yeah, sure.
Ooh, that's like
So now it has some like area of support. So it won't just, it'll be able to print now.
probably, yeah. Yeah, you'd be able to print
It'd be a
on that bottom face. It'd be weird, yeah. You know, a lot of the time when when you're printing something and you don't have a lot of surface area on the build plate, like a lot of connection between surface area and your build plate for your part, and it's a big part, it might fall off the build plate while it's printing, especially with a Cartesian printer, because the
Yeah,
bed
this
is
is an
actually moving
example
back
though.
and forth. Yeah,
There's
if you
not a
were to
lot
flip
of
this
space that's actually touching the build plate and it's a big overhang, so there's a good chance that it's gonna come off the build plate while it's printing and fail.
yeah, so if you go to the slicer, show them how to set connection like brim or
I'll just save it as an STL. Let's see.
curve. Dude, that's what I hope I get in all my classes.
that's pretty good. Okay, I'm just gonna delete this one and put in the new one.
No,
Right.
why would you think we want to print it that way?
This is
Ridiculous.
where how you would ideally print it.
Yeah, but let's say we're not going to do it that way.
Yeah, let's say we want to be purposely inefficient. There we go. Print it like this. Let's say we print with no support.
Yeah. It doesn't need support. 6 hours, dude. Wow.
Yeah.
It's a big.
It would print like this.
Big mama. Big mama.
Usually you don't want to print overhangs like angles that are more than like 45 degrees. I didn't measure this angle, but it looks like a little too much. But it'd still probably work. It just wouldn't look that great.
Yeah, over the course of printing this model, with the bed moving back and forth, it is likely to fall over or just be knocked over or just come undone, and then your print is just ruined. And that will probably happen towards the end of your print, so it'd be a lot of time wasted, material wasted. So you can add under build plate adhesion, you can add a brim, and that'll basically just give you more surface area attached to the bottom. You can also add a raft. And that support material can peel off after you're done taking off the build plate. A raft is like a whole other thing. It elevates your print and prints on top of it. And I don't know if that
I don't know what this
Is that printing in the
weird
air?
glitch.
Yeah, that's.
Whoa, this layer
Wait,
for
that
some
layer.
reason glitched down here.
That is insane. That's
I've
never
never
happened.
seen that before.
That has
But I
never
don't use
happened.
Cura that much. I usually use a program called Prusa Slicer.
I
I
use
personally
Cura all the
prefer
time.
it.
That's never happened ever. Oh
Yeah, I've
my
never seen
god.
this happen, and I used to use this program a lot, so I don't know.
Oh my god. We have it on video too.
It's odd.
That's awesome. But yeah, your
Price.
print would fail definitely. If you ever see something like that, you always should verify your print in the preview tab.
Yeah, it was just a weird glitch. Now it's fine. So you should definitely like look for stuff like that.
Yeah, because your whole print would just fail, and reprinting that same G code would just fail again. Wow, that's
That
crazy.
was odd. Weird glitch. Okay, anything in SolidWorks I should go over? I think
No, I
everything is
think we're
good.
good. Thank you for coming, and I hope you learned something from this.
Yeah,
And if you weren't able to make it, I'm glad you took the time and watched this on our channel at 2 times speed, as you should.
ideally, yes.
Yes. Yeah. You can also even go higher if you add an extension.
Yeah. Okay.
All right. Well, thank you. We're gonna end now.
Yeah. I'll stop sharing my screen.